If we do it just like this, Solidity actually knows that there's an issue here and says, hey, try not to do this. But if we typecast this as a uint8, Solidity gets a little bit more confused and goes ahead and lets us do this. Now, what do we think big is going to be? It should be 256, right? But big is a uint8, and this is the maximum size that it could be. So what happens when we deploy this? We look down. We actually get 0. What happens if we do 100 and we deploy that? We actually get 99. And this is because integers can actually wrap around once you reach their maximum cap. They basically reset. This is something we need to watch out for when working with Solidity. If we're doing multiplication on really big numbers, we can accidentally pass this cap. Luckily, as of version 0.8 of Solidity, it actually checks for overflow, and it defaults to check for overflow to increase readability of code, even if it comes a slight increase of gas costs. You can use this unchecked if you want to have it keep that wrapping functionality. So just be aware, if you're using a lower version than 0.8, you're going to have to do something to make up for this. And we could write a whole bunch of code here basically to check all of our math, or we could just import something called SafeMath from another package. Similar to how we imported Chainlink, we can go ahead and import a package called SafeMath from a tool called OpenZeppelin. Now, OpenZeppelin is an open source tool that allows us to use a lot of already pre-built contracts. We can go ahead to their documentation and go to their utilities and see SafeMath. And they even have a little sticker here saying, SafeMath is no longer needed, started with Solidity 0.8. SafeMath is a tool and a way for us to avoid some of these problems with doing math in Solidity. Now, I'm not going to spend too much time on the contracts that actually fix this, but we can actually import right from the Chainlink directory as well a Solidity file called SafeMath Chainlink. And what we can do is right after our contract, we can do using SafeMath Chainlink for uint256. And what this will do is it'll use SafeMath Chainlink for all of our uint256. And SafeMath Chainlink doesn't allow for that overflow to occur. Libraries are really similar to contracts, except that they're isolated code that can be run in a reusable context. In this case, we're attaching the SafeMath Chainlink library to uint256 so that these overflows are automatically checked for. Just keep in mind, if you're using anything less than 0.8, you're going to want to use some type of SafeMath just to check for your overflows. Now, this is for those of you who are familiar with SafeMath and integer overflows and underflows. We are not going to be calling the functions that SafeMath provides us, like div, add, mul, all those functions. Simply because in 0.8 moving forward, we no longer have to use those, and we can just use our regular operators like plus and minus. So this is great. Our contract is coming along really well. We now have a way to get the conversion rate of whatever F is sent and turn it into US dollar. Now we can set a threshold in terms of US dollar. But how do we guarantee that whatever amount that the users send when they call fund is going to be at least $50? Well, first we might want to set a minimum value. So we can do uint256 minimum USD equals, let's say, $50. And again, since we're using everything in GUI terms, we want to then multiply this by 10 raised to the 18th. And just wanted to take a pause for a second because this line is actually wrong. This should be raised to the 18th. So this line should really look like this, where it has the double star. So apologies, the rest of this has that single star, but it should be the double star here. If you do have the single star though, the rest of the contract will still work fine. So this will be the minimum value. It'll be $50 times 10 raised to the 18th so that everything has 18 decimals. Now that we have a minimum amount, how do we actually make sure that this minimum amount is met in the value that they send us? Well, if you're familiar with if statements, we could do something like if message.value is less than minimum USD, then revert. Or we could do something a lot easier and better practice and much cleaner. We could do what's called a require statement. When a function call reaches a require statement, it'll check the truthiness of whatever require you've asked. So in our case, the converted rate of message.value needs to be greater than or equal to our minimum USD. This line says that if the conversion rate of message.value to USD, if they didn't send us enough Ether, then we are going to stop executing. We're going to kick it out. We're going to say, hey, this doesn't count, and we're going to do what's called a revert. We're going to revert the transaction. This means that the user is going to get their money back as well as any unspent gas, and this is highly recommended. We can also then additionally add a revert error message, something like, you need to spend more ETH. So now let's try this out. As we saw, 1 GUI is going to be way less than $50. So if we send 1 GUI along with this fund contract call, it should kick out and say, you need to spend more ETH. So let's actually try this. Let's go to the deploy tab. We'll get rid of our overflow. We use injected Web3 because, again, we are working with the Chainlink aggregator contracts that are on chain. We're going to move to fund me, and we're going to hit deploy. MetaMask is going to pop up, and we're going to hit confirm. Now, if I try to hit fund, let's see what happens. We're getting a gas estimation failed. It says gas estimation error failed with the following message. Execution reverted. You need to spend more ETH. So the contract isn't even letting us make the transaction. We can go ahead and try to send the transaction, but here's what's going to happen. On Etherscan, once this goes through, you can see that once this transaction finished, we got this status, fail with error. You need to spend more ETH. We don't want to force these transactions to go through. If we look in our MetaMask, we can even see this failed bit here. So whenever you see these gas estimation failed errors, usually that means something reverted or you didn't do something that was required. However, if we go to value here and we spend a lot more, let's say 0.1 Ether, which if we take out our calculator, 2500 times 0.1 is going to be $250. This should easily be well and beyond past our $50 threshold. So let's add 0.1 Ether. And remember, we got 0.1 by adding it in the converter and grabbing the way. Again, the way is the smallest denomination. Now, if we change this to way and hit fund, this should go through. We go and hit fund now. You'll see MetaMask pops up because MetaMask goes, oh yeah, this transaction isn't going to revert. And that's what we want. So we can go ahead and hit confirm. And now we'll finally have sent some funding to our contract. And now that this is confirmed, we can go ahead and grab our address here, pop it into our address to amount, and we can see that indeed our funding has gone through. Now we can be part of this crowdsourcing application with our minimum value, which is fantastic. Awesome. Great job. Awesome. So now we can fund this contract with a certain minimum USD value. In this case, it's going to be $50. Now, you'll notice, though, that right now we don't do anything with this money. So we're going to fund this contract. However, that's it. And we don't have a function in here to actually withdraw the money. So there's no way that even though we just sent this contract some money, there's no way for us to get it back. So how do we fix this? Well, we can add a withdraw function in here. So let's go ahead and add that. Function, withdraw. And this is also going to be a payable function because we're going to be transferring ETH. We'll make this public. And we can do message.sender.transfer. Transfer is a function that we can call on any address to send ETH from one address to another. This transfer function sends some amount of Ethereum to whoever it's being called on. In this case, we're transferring Ethereum to message.sender. So all we need to do now is define how much we want to send. Well, we're going to send all the money that's been funded. So to get all the money that's been funded in this contract, we can do address this.balance. Now, there's a couple of special things going on with this line. First, we're saying address of this. This is a keyword in Solidity. Whenever you refer to this, you're talking about the contract that you're currently in. And When we add address of this, we're saying we want the address of the contract that we're currently in. Whenever you call an address and then the balance attribute, you can see the balance in Ether of a contract. So with this line, we're saying whoever called the withdraw function, because whoever calls the function is going to be the message.sender, transfer them all of our money. So let's go ahead and try this. Let's deploy FundMe. And now let's fund this with a lot of Ether so that we can see it. We'll fund it with one whole Ether so that we can see it go into the contract and get pulled out of the contract. We'll hit the fund button and you'll see we're sending one whole Ether into this contract. Now, if we look at our balance, it's gone down from 17 to 16. Or if you're still at 18, it went down from 18. So let's try to get it back. If we call this withdraw function now, confirm, once this transaction goes through, we should get all of our Ether back. Let's look at our MetaMask, and boom, indeed, we have got all of our ETH back. However, looking at this contract, we can see that, well, maybe we don't want anybody to be able to withdraw all the funds in this contract. That seems like it might be a really bad idea. Maybe we only want the funding admin to be able to withdraw funds. So how do we set this up in a way that only the contract owner can actually withdraw funds? Well, we learned before that the require function can actually stop contracts from executing unless some certain parameters are met. We can do the same thing here with require message.sender equals the owner. But we don't have an owner to this contract yet. So how do we get an owner to this contract the instant that we deploy it? Well, we could have a function called create owner. But what happens if somebody calls this function right after we deploy it? Well, then we wouldn't be the owner anymore. So we actually need a function to get called the instant we deploy this smart contract. And that's actually exactly what the constructor does. So typically at the top of your smart contracts, you'll see a constructor. And this is a function that gets called the instant your contract gets deployed. We don't even need to do add function here. We can literally just call it constructor because it's what constructs the smart contract. So we'll make constructor public, and whatever we add in here will be immediately executed whenever we deploy this contract. So one thing that we could do is we could have an owner be set the instant we deploy the smart contract. So in the top, we could add address, owner. And in our constructor, we could say owner equals message.sender. Because the sender of this message is going to be us. It's going to be whoever deploys this smart contract. We can even test this out in the JavaScript VM to be a little bit quicker because we're not actually going to be calling the fund or the get price function for now. Oops, let's also make this public so that we can interact and see this owner variable. So now if we go to FundMe, we deploy this in the JavaScript VM, we should be able to see who the owner of this contract is. And it should be our address because this constructor function should have been immediately called the instant that we deployed the smart contract. Awesome, we can see the owner of this smart contract is indeed our wallet. Because remember, when we're working with the JavaScript VM, our wallet is these fake wallets that they kind of give us. We can even try this with an injected Web3 with deploying this. And the owner should be this OX757, etc. address. Let's go ahead and look at FundMe, see the owner, and we do indeed see the owner is us. Okay, great. Now we have an owner. We can go down to our withdraw function and use that same require. So we can call require message.sender equals owner. Equals is the way that Solidity understands true false. We're saying that message.sender has to equal owner. Now let's go ahead and try this. And we'll try it with the JavaScript VM again for speed reasons. Let's deploy this FundMe. And if we go down here, we can try to call the withdraw function. And it looks like it is successful because currently this is the address that deployed the contract and it's also the address that is calling withdraw. However, if we switch to a different account and call withdraw, you'll see that Remix actually freaks out down here. It says, uh-oh, something wrong happened. And this is essentially the